Hey everyone, welcome back to the episode 2 of our data engineering masterclass. In our last episode, we broke down exactly what data is and why data engineers are the unsung heroes of the tech world, right? So if you missed that, definitely check out the link in the description first. Okay? And now today we are taking our next big step. So every single app you open, whether it's checking your WhatsApp messages or ordering lunch on Zomato or transferring money on Google Pay, everything needs a safe, secure, and lightning fast place to store its data, right? So in tech word, we call this a database. But if you are preparing for interviews or looking at job description, you will often hear two terms, SQL and NoSQL, or relational and non-relational databases, right? So why do we have two types? Which one is better? And how do you choose? So today we are going to break this down using the simplest everyday example. Okay, so let's dive in. So before we talk about SQL or NoSQL, what is a database at its core? So first we'll understand that. Okay. So think about how you store phone numbers. So if you write your friend's phone number on random messy sticky notes and scatter them all over your desk, what happens? You lose them, right? They will get dirty. And it will take you forever to find one when you need to make an urgent call, right? So what do you do instead? You use the contacts app on your phone, right? Your contacts app is a database here. It is a highly organized digital storage space where every single contact is saved in a neat, searchable, and secure way, right? So in the software world, our database is just a highly engineered version of your phone's contact app. It is built to handle millions of requests, search through billions of records, and fetch exactly what you need in a fraction of a milliseconds. Right? So that is our database is all about. And now let's talk about the relational database first, right? So which we call SQL. Famous examples are MySQL and PostgreSQL. Okay. So think of a SQL database like a strict school attendance register, right? So in an attendance register, every page is pre-printed with grid or unchangeable columns like roll number, name, class, and date, right? So you can't decide to suddenly draw a picture or write a paragraph inside the roll number column, right? The register forces you to follow the rules. So in tech, we call this a strict schema. So you must define your table's layout before you can write a single line of data. Okay, and why is it called relational? Because different pages talk to each other. For example, you have a student's register and a fees register, right? So instead of writing the student's name, parent's name, and home address on both pages, the fees register simply point to the student's roll number, right? So that way they are related. So this rigid structure is incredibly secure. It guarantees zero mistakes, which is why banks and financial companies absolutely love SQL. So that's relational database is for you, where we need to define the schema upfront before we ingest any data in it. Okay, now let's take a simple real life example for SQL database to show how strict this is. So look at this slide. So if you look at this age column, it has values 24, 29, 31. These are the integer value. So if we store any integer value in this column, the database says perfect allowed. Okay. But if we try to type the text like 24, 29 using alphabets, the database instantly blocks it and throws an error because we have already defined this data type of this column integer. So we won't be able to save any other data type value in it. So it is like trying to write your name in the date of birth box on a government form, right? So the system simply won't let you submit it. So this usually prevents human errors and guarantees that your data is always 100% clean and correct, right? So this is a strict rule of a SQL database. Like we need to predefine the schema before we ingest any data in it. And if we try to ingest any other data type value in that column, database won't allow us to ingest that data. Okay. Okay. So in the previous slide, we have covered the SQL database, right? Now let's cover the non-relational database, which is NoSQL. So as we know, as the internet grew, our data started getting incredibly messy. We weren't just storing clean tables of names and roll numbers anymore. We had to store profile photos, live locations, voice notes, and YouTube links, right? So this messy, fast-moving data broke the strict rules of SQL, and that is why non-relational databases or NoSQL were born. Example includes MongoDB and Redis. Okay, so think of a NoSQL database like a WhatsApp chat window. In a WhatsApp chat, there are no rigid rows or columns. It is completely flexible, right? Like in chat 1, you might send a simple text message. In chat 2, you might send a contact card and a PDF document. In chat 3, you might send a voice note, a photo, and a live location map, right? Does WhatsApp block you and say error? You must send a text message before you can send a photo? No. It accepts whatever you throw at it instantly, right? So this is what we call schema-less NoSQL. Okay, so NoSQL databases don't care about fixed rules. They are built for extreme speed and massive scale, which is why companies like Instagram, Uber, and Netflix rely on them to handle millions of dynamic posts and messages every second. Okay, okay, now look at this screen. So instead of a rigid grid with fixed column, NoSQL stores data as individual files, which we call a document. Okay, so let's look at our two users. On the left, we have Rahul with document 1. So when Rahul registered, he only gave us his name and his age. The database saves this simple record, no problem. Okay. But on the right side, we have document 2 for Amit. Amit signs up, but he doesn't want to share his age. Instead, he links his Twitter handle and signs up for our premium plan. Okay. In a strict SQL database, this would cause a headache. We would have to go back, modify the entire table structure, and add new column for Twitter and premium, right? If it is a SQL database. But in NoSQL, it just works. The database doesn't care that Rahul has an age but no Twitter, or that Amit has Twitter but no age. NoSQL takes whatever data you write instantly. This is why apps can launch new features in minutes without breaking the system, right? So that's the difference between SQL and NoSQL. We'll cover more differences in the next slides. See a simple database comparison sheet. This is the differences and comparison between SQL and NoSQL databases. Okay. So SQL database is like it is extremely structured. It organizes data into strict tables like column and rows and requires a rigid blueprint first, like it is a set of rules before you can store anything in it. Right? On the other hand, NoSQL is highly flexible. It stores data like a collections of folders or documents, allowing you to save data first, write first, without strict layout restriction. Okay. Then second difference is like SQL is scales vertically, meaning you make this system more powerful by upgrading to a single larger and more powerful server. On the other hand, NoSQL is horizontally scaling, meaning you grow by connecting multiple cheaper storage servers together as a team. I will cover the scaling part in the next slide. And if we see the best use for SQL, best for high accuracy systems that can't afford any mistakes like banking accounts, financial networks, and ledgers, right? On the other hand, NoSQL best for handling massive, fast moving, and unstructured data like social media feeds, chat messages, and live activities log. Okay, so that's a small difference between these two databases. In next slide, we'll be covering what is scaling and what is the difference between vertical and horizontal scaling. Okay, now in our comparison cheat sheet, we saw the word scaling, right? So what does that actually mean? Let's look at the screen. So imagine you run a local pizza delivery shop and suddenly your orders double overnight. So how do you handle that scenario? So you have two choices on how to handle this. So first is vertical scaling. Okay. So think it's like saying I will buy a massive multi-crore monster truck to carry all the pizzas at once. That's the first solution. And in technical term, this means you take your single database server and buy more RAM, a faster processor, and more hard disk space to make it a supercomputer. Okay? So it is super easy to manage because you still only have one machine to look after. But there's a catch, which is the physical limits. No matter how much money you have, a single computer can only get so big because the manufacturers simply can't make it any faster. Okay, and on the other hand, we have horizontal scaling. So instead of buying one giant expensive truck, you say I will hire 10 normal delivery riders with standard scooters. Okay, and in tech, this means instead of upgrading your computer, you just hook up 10 cheap normal computers to share the workload. If your traffic doubles again next week, no problem. Just add 10 more scooters to this network. Right? So there is virtually no limit to how much you can grow. This is exactly how global giants like Netflix and Instagram handles billions of active users every single day without their apps even crashing. Right? And if we talk about the price differences, so upgrading a single server to a supercomputer, which is vertical scaling, becomes exponentially expensive. While buying normal commodity servers like horizontal scaling is highly cost effective. So that's why horizontal scaling is much preferable than in comparison to vertical scaling. And this is for NoSQL, this is for SQL. Okay, now let's look at this slide which compares the two core philosophies behind how databases handle data in transaction. So how SQL handles it and how NoSQL handles it, right? So in terms of SQL, we follow the ACID rules, which is all or nothing execution. So it stands for atomicity, consistency, isolation, and durability. And how it works? So it guarantees 100% data accuracy. If a process like a bank transfer fails halfway through, the database cancels the entire things and rolls back to the start, so no money vanishes into thin air, right? So it is like it's provide us the absolute accuracy over speed. On the other hand, the base rule for NoSQL is speed first, consistency later. So what it stands for? Basically available, soft state, eventual consistency. And how it works? It prioritizes availability and blazing fast speed. If you post a photo on social media, the system doesn't wait to update everyone worldwide at the exact same millisecond. A friend nearby might see it instantly, while a friend across the globe might see it a couple of seconds later. The data eventually becomes consistent everywhere. Okay, so the priority of this high speed and availability over instant synchronization. So each database has its own pros and cons, and this is the basic properties difference between NoSQL and SQL, acid versus base. Okay, now let's interact below. So this is a challenge for episode 2. So just think about this scenario, like structuring Zomato's food backend. So imagine you are hired as a junior data engineer to build the data foundation for a major delivery app. Where where should you store the customer's order checkout history? A strict SQL ledger or a highly dynamic NoSQL for document folder? And why? Just think about it and try to answer it. If you have any doubt, issues, please did reach out to me in the comment box. I will definitely try to help you. Okay. And in the next videos, I will be covering the SQL foundations, the basic selects where and multiple joins, and maybe some other topics related to SQL. Till then, thank you for watching my videos. Take care. Bye bye.